right? So in today's class, we'll study about some advanced ER model, which is also known as enhanced entity relationship model. So we'll study something about generalization and specialization in today's class, and how to represent generalization and specialization, right? So for example, person entity set is a generalization of employee entity set and student entity set, right? So at the top level you have the base class, which is going to be the person entity set. So the person entity set is the generalization of both the employee entity set and the student entity set, right? So a person contains the attributes ID, name, street and city, whereas the student entity set is characterized by total number of credits he enrolls in a semester, and the instructor or the employee entity set is characterized by the salary attribute, right? So employee and student entity sets, they are going to be specialization of person entity set, right? So employee and student entity set, they are going to be the specialization of the person entity set. And the other way, if you take a in a bottom-up approach manner, person entity set is a generalization of employee entity set and student entity set, right? So again, the employee entity set can be further specialized into instructor or secretary, right? So whenever you have this form of generalization and specialization, how to represent specialization, right? So a person is going to be a generalization of student and employee. So a person contains the attributes ID, name, street and city, and the student contains the attribute total credits, right? So we are going to represent a student entity set in the case of specialization by ID, comma, total number of credits, and employee again we are going to represent it by ID, comma, salary, right? So this is how we represent a specialization via schema, right? So a person entity set is a generalization of student entity set and employee entity set, right? So person entity set is the base class, and the student entity set and employee entity set, they are going to be the derived classes, right? So they are the specialization of the person entity set. So person entity set is represented by ID, name, street and city. Student entity set is characterized by total number of credits, and employee entity set is characterized by salary. So whenever you are going to represent a student entity set, you are going to represent it by ID, comma, total credits, whereas employee entity set is represented by ID, comma, salary, right? So here the drawback in this way of representation is that accessing the employee relation, right? Getting information about an employee relation requires accessing two relations, one corresponding to the low level schema and the one corresponding to the high level schema, right? So for example, I want to access the employee details. So the salary is present in one schema, whereas the employee details is present in the person's schema, right? So I need to execute or access two relations to get the details about the employee, right? So the other way of representing specialization via schema is that we can go for you can form a schema for each entity set with local and inherited attributes, right? So for example, a person is going to contain ID, name, street and city. Student is characterized by only total credits. Anyway, it is going to inherit the features of person, so it is going to contain the attributes ID, name, street, city and total credits, right? And similarly, employee is an entity set. That is a specialization of person entity set. So it's going to inherit all the attributes from the person entity set. So it is going to contain the attributes ID, name, street, city and salary, right? So however, the drawback in this method is that there is redundancy in data storage, right? So the name attribute, street and city may be stored redundantly for both the person stored redundantly for people who are both students and employees, right? So there's a redundancy while you represent this information in this format, right? So in this case, you are going to have both the base attributes as well as the derived attributes, right? The inherited attributes as well as the local attributes defined for each and every schema in the case of specialization, whereas in the first case, you are going to have only the inherited attributes will be only the ID of the particular person, right? So this is how we represent generalization and specialization. So generalization is going to be right. A person is a generalization of student and employee, right? So generalization is a bottom-up design approach. It combines a number of entity sets that share the same features into a higher level entity set. So specialization and generalization are simple inversions of each other, right? So specialization and generalization are simple inversion of each other. They are used to represent an ER diagram. So the term specialization and generalization can be used interchangeably, right? So the last topic in the representation is that how to represent an aggregation relationship set. So how to represent an aggregation. So a student is guided by a particular instructor on a particular project, right? And a student instructor project combination may have an associated evaluation. So whenever you are going to represent the relationship set evaluation for, it is going to contain the primary key of the aggregated relationship, right? So evaluation for is represented by the attributes student ID, project ID, instructor ID, and evaluation ID, right? So it's going to have the primary key of all the participating entities: student ID, project ID, instructor ID, and evaluation ID, right? So this is how we represent an aggregation via schema, right? So let me show you the diagram, and with that we'll complete ER model.